Hello everyone. Today we are going to talk about llama.cpp. This is GitHub repo, mainly for inferencing different models from Hugging Face or anywhere else, different large language model, and you can run this any large language model locally with the help of llama.cpp. If you search for llama.cpp GitHub, then you would see the repo. It is kind of very familiar repository recent days. Many people are using this because it is quite great. You can see how familiar this repository is. So what is this repo exactly for? So in the about section, you would see like this is LLM inference in C++. So that's the main purpose exactly. It is built in C and C++. That's mean it is kind of very lightweight application, and this is for LLM inference. Since it is in C++, so its inferencing rate would be a little faster. That's the main thing in this repo. You can read the documentation of llama.cpp. Here is the README for this. You can explore all the things like how to use MTL reset something, GPU memory active. How can you do that? VSCode extension and other things. You can explore this. Most importantly, description. In the description, you can just see what is this. The main goal of llama.cpp is enable LLM inference. This is the main thing I already said. This repo is mainly for LLM inference. How it can make inferencing very faster based on your your computer configuration, RAM, memory size, and other things as well. There is the detailed description you can read, and the important point here is just this line is quite important because you can see 1.5 bit, 2 bit, 3 bit, 4 bit, something like that. So in lower bits, usually any large language model is 32-bit large language model or 16-bit large language model. That's why that those models are quite big in size. You can see here, like in Hugging Face, if you go into model section, you would find lots of models. And this model, most of the model are built in floating point 32-bit or more than 32-bit or 16-bit, something like that. That's why these models are too big. So you can see here DeepSeekR1. This is the most talked just large language model in this week. So you can go into the files and versions, and you would see like the set tensors. This is a huge model, approximately 700 gigabytes of memory take. And if you go into a set tensors, the architecture of the model and the shape and the precision, most importantly precision, you would see like just the bit size is 16-bit or floating point 32-bit. So most of the things are just like 32-bit model. That's why these models are too big. Each set tensor is quite more than 4 gigabytes of memory. So if you want to download this entire model and want to run your local machine, then it is quite big model. Like you have to download 700 gigabytes of set tensors, and you need to inference in your local machine. Since this model is too big, so your inferencing would take a lot of time. Like a simple question, if you ask this LLM, if you run it locally, then it would take quite just 1 hour or 2 hour or more than hours for the inference to just give any response of that model. That's why llama.cpp comes into play. It's usually quantized the 32-bit model into one of the bit here, like 1.5 bit, 2 bit, 3 bit, 4 bit, or anything. So the model should be quantized. That's why the model size would be reduced significantly, then it can run in your local machine. Of course, there are more configurations, more just systematic cases here handled. So that's the main purpose of llama.cpp. You can explore this repo and you can contribute if you want. There should be a contribution guide for sure. It is quite familiar repository. Okay, and this is the intro. So if you want to use this llama.cpp, there is some installation guide. You can read all the things, but I would suggest if you go into just how you can building the project. That is the main thing in here in the installation process. So here it is called how to build. This is the main thing exactly. If you follow along the guide, then you can run anything. So another thing I want to just share with you, like in DeepSeekR1 or normal models from Hugging Face, this is not a quantized model. These are the base model. That's why their precision is kind of like floating point 32. So if you want the quantized version or a version that is compatible with llama.cpp, then you need to have the tensors not in .set tensor, rather .gguf. Your tensor should be .gguf format. Okay, so you can find the .gguf format tensor in Hugging Face. Like if you go into the Onslaught AI, if you search for Onslaught, and you can see a lot of bunch of models in here, DeepSeekR1 versions. Go into here, and you would see all the models in here that is in GGUF format. I already said the model should be .gguf format if it is going to be compatible with the llama.cpp. Okay, so if you go into the DeepSeekR1 GGUF in the files and versions, you would see like all the set tensors are in format of .gguf. This is very crucial. .gguf, all the models are just like .gguf. So if the model is .gguf, then you can run this model locally with the help of llama.cpp. You can see the file setup, the architecture, and the weight setup and everything in here. So in .ggef, there is everything like all the tensors, also the chat templates, all the special tokens of this model used in the pre-training, all the tensors and other things. So it is kind of like a standalone tensor that holds the model architecture, the tokenization process, the special tokens and other things. So this is a standalone thing. So you can directly run this .ccpf in your local machine. That's the main goal we are going to focus. Okay. Okay. Now just llama cpp. I'm going to build this in my local machine. There is an installation guide. So I'm going into here. Okay. First of all, what I'm going to do, this is like I need to clone the repo. very fast. I'm going to do that. But before that, you need to remember this llama.cpp. This is available in Mac OS, also Linux, not in Windows. This is very important. Since I'm in Windows PowerShell, it is not supported yet now. So I need to just change my terminal into Ubuntu WSL. Okay, I installed Ubuntu. So if you are in Windows and you don't have the Ubuntu or Linux or something, then you need to install Ubuntu or Linux from anywhere. But if you already have Linux, then it should be fine to go. So if you don't have Linux, then you can just go into the Microsoft Store. From here, you can search Ubuntu, and there is a bunch of Ubuntu just application. You can install any. Okay, then you can run the terminal like in the Ubuntu section. This is the terminal. You can just run all those things in this terminal. If you have Windows, but if you are in Windows machine, okay. So now I am in WSL terminal, and I will follow along the things. Like first of all, I need to clone this repo. It is going to clone. It will take a little bit of time because this llama.cpp is quite heavier probably. So after cloning the repo, there is a bunch of options. Like if you want to build this llama.cpp server in your CPU, then this is just a simple two commands. If you run these two commands, that is fine to go. There is no need for anything. But since if you have CUDA, then it would be a little bit faster because there should be parallel processing or something. So first of all, if you don't have CUDA, like if you don't have CUDA toolkit or NVIDIA or something, then you can build just using CPU build, just running two commands in there. But if you have CUDA, go downside. There is an option like CUDA, but you need to have a CUDA toolkit for sure. Also CUDA driver or something. If you don't have, if you have just zip, if you have NVIDIA or something, but you don't have CUDA toolkit, then you can install CUDA toolkit from the CUDA from the just NVIDIA official official website, and you can follow these things. It would be a little bit faster because there is parallel processing to happen, but in CPU there is no parallel processing. This is kind of like it would take a little bit of more time rather than CPU, rather than CUDA or something. Okay. Oh, so CPU build is very simple, just two commands to run, and there is little bit more configuration or commands for better performance. You can just you can follow this documentation, you can explore things out. And in CUDA section, this is very crucial. So first of all, I already said you need to have CUDA toolkit. How we can check if you have CUDA toolkit or not? You can go into the Ubuntu. You can go into the Ubuntu terminal. You can just first of all you can run NVIDIA SMI. That means you have CUDA installed. You have NVIDIA CUDA installed in your machine. This is my configuration, and you can run nvcc version. It is going to check you have CUDA toolkit installed or not. I installed CUDA toolkit, but I didn't I installed in my just Windows, but I didn't install in my Linux. That's why it is not going to show anything. But you can install CUDA toolkit, then you would see the version of the CUDA. So since I have NVIDIA GPU, but I don't have CUDA toolkit, that's why I'm not going to use the CUDA section. But if you have, then you can follow this CUDA section. It would be a little bit faster than the normal CPU. Okay. The cloning is done. You can go into the file. There is bunch of files. There is bunch of files in here, llama.cpp. Now you cloned this. Now run this command. I need to go in. I need to change the directory to llama.cpp. Then the building section. But before that, you need to have CMake installed. That is very crucial. If you don't have CMake, then you need to install CMake. How we can install CMake? If you ask the like ChatGPT or something, you can ask like how I can install CMake in my Linux. Okay. If you run these commands in your Ubuntu terminal, then through that you can install CMake. So after installing CMake, you can run this command like cmake-b build. Okay. I believe you installed. It is going to build the CMake. It will take a little bit of time. After that, we would just use this command. It's kind of very simple. It is taking a little bit of time because there is a lot of things to build, a lot of configuration, a lot of just system management, my local machine, and other things. So a lot of things to consider. That's why it took a little bit of time to configure and to build the llama.cpp environment or something. Okay. In the meantime, we can download something. Like I need to have a .gguf format tensors. So I'm going to the going into the what? Okay, since this process is done, I can run the second command. Okay. Now, what I need exactly, I'm going into the DeepSeekR versions. This is the 1.5 billion GGUF since I'm going to experiment. So it's a little bit of smaller models. That's why I chose this model. In the files and version, you would see like all the .gguf file format it, just say tensors or something. So to run llama.cpp, to run any of this, your set tensor must be in format .gguf. I previously said. So you can download any. Like I'm going to download this model. It will take little bit of just 718 megabytes. Since I've already downloaded these models, so I'm not going to download. In my download section, I've already downloaded all of these weights from Hugging Face, so I can use any of the model if I want to. Okay, this is building 16% down. It will take a little bit more time. Okay, I just need to wait. Okay. Now after building all those things, what I can do, I need to run the model. I need to just you need to go into below, like here you would see .build bin llama.cli. Since my llama.cpp is already built, so I need to run some commands to run the model I downloaded from Hugging Face in my local machine. So I can follow these things. For that, so in the other documentation, you'd see here the main CLI command line interface. In this section, if you read all those things, you would just quick start common option input prompts and other things. You would find out all the just commands to run the model you downloaded from Hugging Face. So you can follow these things, like, so if you just if there is a this is the llama CLI command line interface. -m means the model. The model you downloaded from Hugging Face. Like you can clearly see the model is .ggef format. Then you can provide a prompt. This is the thing. Okay. So you need to explore all those things. I'm not going into deep. This video is going to little. I'm not going to cover all those things. The video is going to be lots. Okay. So what I can do now, since I downloaded the all the tensors, now I need to just pull the tensor in my llama cpp folder. Here is section like models. In the model section, there is previewable. A lot of .ggef files are there. This is just previewable. We don't need anything to with that. But I need to just place my model. Like I can place this model in my VSCode in the model section. Okay, this model is loaded in the model section. So you need to be careful that you can place the model in the model section. Okay. So after the building process would be done, we would run this model locally with different prompts. We can check this model is performing better or not. Okay. Since it is taking a little bit of time, we can explore more things in this case. So if you go into the onslaught, you will find out a lot of things in here, like a llama, ZRPO 5.4, llama 3.2, and other things. They use the same format, like .ggef format, and they use the same thing using llama.cpp or something. They fine-tune a lot of fine-tune models with faster inference and other things. I believe they use llama.cpp or something. Okay. You can explore Onslaught. There is a lot of things to learn from here. Also, if you heard about lmstudio is also built with the help of llama.cpp. In lmstudio, you can run any model you want. Like if you go into the lmstudio, it's not done, it's 65%. So in the lmstudio, what you can do exactly, you can select a model, like you can select the model and run anything. It is locally, there is no need for internet connection or something. So in this is just built with the help of llama.cpp. Like you can ask any question, it is going to answer. So even in the time, if you don't have the internet connection, it would respond. Okay. So you can explore LM Studio. There is bunch of models out there. Okay. It's 72% done. It is going to take a little bit of time because a lot of things to manage, configure based on my laptop, based on my other things, my installations and others. That's why it take a little bit of time. I would suggest just in llama.cpp, you can explore a lot of things like description. Here is just the models. You can run a lot of models from here. These models are supported by llama.cpp. Also multi-model, bindings, UIs, user interface, tools, infrastructure, games, and other things. Okay, how you can build the project, obtaining and quantizing the models. So you can have a model that is in shape tensor. How we can make that model into .gguf just using different quantization method. Here the quantization is done. Q means quantization. So how we can do that? There is a guide like obtaining and quantizing models. How we can just make models quantized and compatible with llama.cpp. You can explore these things. There is like different command client interface, and also in .ggef format you can explore this file format more. llama.cli, there is llama.cli command line interface, llama server, llama perplexity, llama pains, llama run, llama simple. So a lot of options, a lot of diversity. You can explore all those things in this GitHub repo. Okay, this is a huge repo, and it is just a lot of people are contributing every day. Okay, you can also contribute to understand how under the hood everything is working. There is another GitHub repo that is like llama.cpp Python. You can search in the browser. So that is built on top of llama.cpp, but there is a Python-based syntax. So you can explore that thing also, like llama.cpp Python. So you can explore this repo also. This would be a little bit easier to learn because in llama.cpp there is a lot of command line interface and it is not Python alike. You can run different commands. If you're not familiar with different command line interface or something, then it would be a little bit tricky for you. But there is an option. You can use llama.cpp. Here everything is just like there is a lot of things like a Python interface for this model from llama.cpp. You can import llama.cpp, providing the model, then just prompt template and other things. This is quite easier. I would make on video in llama.cpp in Python probably later, but you can explore these things also. Okay, this is 90% building is done. Okay, building process is done. That's fine. Now what I need to do exactly, in the model section, I just from my storage, I place a DeepSeekR1 distill queen 1.5 billion. This model, I'm going to call this model. Okay, for calling this model, there is some command. You can run this command here. If you see this command, like first of all, the llama build.build being llama CLI. So llama command line interface. And here, if you provide dash m means the model you're going to use. The model is just model DeepSeek. So which model I used here, like Queen 1.5 billion Q80-0. So you need to name the model. 1.5 billion Q8-0. This is the exact model. So in the I'm just going to use common client interface, this, then dash m for the models, and dash p for the prompt. So I'm going to run this model and using the prompt, and there is a set template or prompt template. You need to just provide this thing like a user section and a assistant section, and inside you're going to call this text as a prompt. Okay, like dash p Okay, this is going well. The inferencing is going to take place. You can see here a lot of information from that model, like you can explore all those things. DeepSeekR1 Queen 1.5 billion. There is a lot of metadata. Also, this is tokens, vocabulary size, configuration, number of layer, number of height, KB cache, and other things. There is a special tokens out there. It is little bit taking time in the first place. Yeah. The important thing, you can just run any model. You can run any .gguf model in your local machine without any hazards, without any just a lot of configuration, lot of system management and other things. Just using llama.cpp, you need to just follow a simple thing, and you are going to just use any model you want from just Hugging Face that is in compatible format with llama.cpp. That's the main. I repeat, so any model that have the .ccuf model, like you can download these tensors and you can run with the help of llama.cpp. So you don't need the all the tensors in your don't need to download, because it would take a little bit of lot of memory, RAM, and other things. So you don't need all those things. Just run a single model, and if it performs better, then you can fine tune also if you want. With the help of llama cpp, there is some guides how we can just fine tune another thing. Okay, that's fine. First of all, you need to check this single just 1.89 gigabyte of model. It is performing good or not. If it performs good, you can explore with the different prompts. If it performs good, then you can ask, you can just fine tune, or you can just this is this is a good thing that just using the set tensor, using the tensor, a LLM you are building. Okay, it is going to take little bit of time. If you go into Slot, there is a bunch of just blog post and other things, community and other things. You would find a lot of models that is compatible for with llama.cpp. You can install any of the model. Like you can download you can download any model, like any tensor. It is going to take 12.33 gigabyte. So if you download all the models, it would take a lot of memory, and you can't probably run in your local machine if the configuration of your machine is not compatible with this. So better you can just download single one, and you can invoke, you can run in your machine. That's a good thing. Okay. Okay, the process is done. So what is 1 plus 1? It is going to just output 1 plus 1 equals to 2. You can ask any question like, what is the revolutionary research paper till now? So I ask a question, what is the revolutionary research paper till now? It is going to think, and it is just a lot of things like the thinking process. Okay, I'm trying to figure out what revolutionary research paper there is in the field of technology. I know that research paper are documents and summarize the findings of academic studies, experiments, or investigation conducted by researchers. So a lot of things it thought about. Okay, that's fine. You can ask different question, a programming question like create a Python snake game, write code. So what is wonderful exactly? Like you have an .ggf tensor, and you can invoke that tensor. You can invoke that thing in your local machine. That is quite good. Like it is going to write the Python code and other things. A single model that is 1 GB of size, but it is going to output a lot of just interesting responses. So that's the main just interesting point of llama.cpp, that you can just based on that single file, you can just run the model locally in your local machine. That's wonderful. And there is no bindings, like no number of tokens it is generating, you need to pay or something. There is nothing. Even if you run just without the network connection, it would be okay. That's the main thing. And there is no bindings in token generation. It can generate lots of tokens, and it's quite faster also. There is no just a kind of nothing, no bindings, nothing, no prior. There would have some privacy based on the previous pre-trained knowledge. Like it can't generate responses. That is piloting the privacy standard or something, but it can generate a lot of tokens. Like I asked a question to create just a snake game, create a Python snake game with the right code. It is in the thinking mode. Then it is going to write the Python code, a whole bunch of code. I can just run this code into any browser. I hope it would perform good. The main thing, it is just a lot of description. The response is kind of very interesting. The response is kind of good because the model is just 1.1 gigabyte of memory. You can imagine, like the performance is too good. You can ask a mathematical question or something, any question you want, like write the mathematical equation of Maxwell's magnetic field. You can ask any type of question, and it is kind of quite faster, and the responses is kind of good. It's not like the random tokens, it is providing random answer or something. The responses is kind of good. So I need to figure out the mathematical equation. The reasoning capability is kind of good. It is also going to write the mathematical equation and other things. This is magnetism, Gauss law, and other things. So you can call anything you want. So what is the main thing? The main part is you can have different models. You can download this model. It's 12.3 gigabyte, and using the process I did, you can just run the model. You can invoke the model without any network connectivity, without any uh, privacy concern and other things. Also, if you want, you can fine tune this model. There is some guide also I'll talk about later. But main thing, this is your own AI. This is your own large language model. So you can play with this large language model, whatever topic you want, whatever just research, anything like that. The performance is kind of good. It's not that bad, and it is going to create a lot of tokens. And there is no just you don't need to pay any company or something based on the tokens. You can generate millions of tokens, billions of tokens. There is nothing, but still this performance is not good. But if you just download a weight from a just a well-known just model, the performance must be good if it is retained on a high quality data, and the performance is good. Okay. Okay, it is quite interesting. The main thing, first of all, I can, if you summarize, like I need to clone this GitHub repo, and then in the model section, in the model section, I need to put the .gguf format model file in here. Then in the command line, I can just call these things like the providing the model and providing the prompt. There is other things like interactive terminal, or number of jobs in CUDA programming, and number of threads, and other. You would find the syntaxes, the command line interface syntaxes in the llama.cpp. So I would encourage you, you can explore llama.cpp for more experiences and other things. It would be a little bit very interesting. Your inferencing would be more faster. You just say, you just saw my inferencing was a little bit faster. I used just my CPU, but if I could use like my GPU, then it would be more faster. So I believe you would explore all those things. Okay, that's the main thing. That was my main purpose, to see you how we can run any GGUF format file. I can invoke locally with the help of llama.cpp. You need to go through the build section, how to build, then just to clone the repo, then just build this using CPU build, or also optional you can use CUDA if you have the CUDA toolkit and NVIDIA GPU or something. So you can just run these two commands. In the CUDA section there is two commands also. That's it. It is very easy and nothing you need to do. Then just then the you need to the your GGUF format file in the model section, and you can using the command line interface, just you can run this, just providing the model name and the prompt and other things. Okay, that's it for today.